Hi, I'm Brian and I work on the GitHub application security team. And today I'm going to talk about GitHub's Bug Bounty program and take you a bit behind the scenes. If you're not familiar, GitHub's Bug Bounty program awards researchers for security findings that they report. Over the past 6 years, we paid out over $1 million to security researchers. Usually, if you're looking from the outside in, you see a submission and then eventually a bounty if the report was valid. Now, that time in between is actually really interesting, but we don't often get a chance to talk about it. So that's what I want to explain today. What happens between someone submitting an issue and a bounty getting paid? So one day I saw this come through Slack. Non-Aardvark reported OAuth flow can be completely bypassed using cross-site head requests. So our OAuth flow allows third-party integrators to act on behalf of GitHub users. Normally, this is gated by users having to explicitly opt in to this connection. However, non-Aardvark is saying this can be bypassed by using a cross-site head request. If this report is indeed true, this is a really severe issue because it basically means anyone can access anyone else's GitHub account and act on their behalf. Oh no, this is a legitimate issue. So now it's time to get everyone on board. So we spin up a Zoom call, set up Google Docs, and keep chatting through Slack. So we loop in 3 different teams that are mainly responsible for dealing with this issue. Security Incident Response Team, their job is to figure out, has this been exploited in the wild? My team, the Application Security Team, asks how and when was this introduced? Are there similar vulnerable code paths? And is our GitHub Enterprise Server appliance also vulnerable? Finally, engineering gets started working on a fix. So as these teams are working, we identified that there's no evidence of exploitation. This is great. We checked through our logs and we found the only people to access the path that would indicate that this has been exploited were the researcher and our team. Unfortunately, this issue was introduced a while ago. We found similar vulnerable code paths, and we found that our GitHub Enterprise Server appliance is also vulnerable. Luckily, this was a pretty easy issue to patch. Luckily, engineering got a fix deployed in about 3 hours. This is awesome. This means GitHub.com is no longer vulnerable to this issue. However, we have to make sure we cross our T's and dot our I's. We went through and fixed all similar code paths we identified. We prepared GitHub Enterprise Server backports, and we decided on a payout for the researcher. Now some key insights. So it's really important to keep everyone on the same page. Since this issue is new to us, and everyone's trying to figure out how it works and what we need to do to fix it, it's really important to share information across our team, the engineering team, and the security incident response team. It's important to react quickly. Since this is such an impactful issue, any extra minute that it spends available in our production infrastructure is causing risk to our customers' data. So we want to react as quickly as possible. And we never want to leave loose ends. So we made sure that we patched all GitHub Enterprise Server versions that were vulnerable to this issue, and we tested each one to make sure that our patch was applicable to all those previous supported versions. So that's a peek behind the scenes of GitHub's Bug Bounty program.